Hi guys, in this video we are going to see top 9 things that you need to consider for designing a sheet metal part. Point number 1, material. When you are designing a part in any CAD software and if you are assigning it to the workshop, make sure you have the right material allocated in the drawing. Otherwise, it is going to waste some time in figuring out what material you need or what material it's supposed to be cut from. It is very important to consider where your part is going and how you are going to use it. So you need to consider what material, for example, are you going to using aluminum, stainless, mild steel, or what kind of grade that you are going to use for this particular parts. Now, point number 2 is thickness. You need to consider the right and appropriate thickness for this sheet metal cutting. When you design this part, you need to have a similar or same thickness across the whole part or minimum thickness changes in the whole assembly. That way you utilize the maximum efficiency and minimum setup time change when we are making the parts in the fabrication workshop. So point number 1 and 2, which is material and thickness, you need to consider about thinking how strong they are going to be, how durable they are going to be, and is it going to be too heavy or is it going to be too flexible or too light for the use that we are going to use. You need to consider all these points before you decide material and thickness, and make sure you have the right material and right thickness listed in the drawings that you are going to give in the workshop. Point number 3 is cost. So when you're designing a part in sheet metal, it is normally start getting expensive as you increase the thickness. Also, if you change the material or if you change different material and different thicknesses in the same part or in the same assembly, it increases the cost. If you require something strong and stiff, consider having an extra fold instead of having an extra thicker material to make that happen. One more thing to add on to this topic is what material you choose affects highly on how you're going to price it. For example, mild steel is one of the cheapest material available for sheet metal, but as you change the grade, the price increases or price changes. Now, point number 4 is really going to be very important because this is where I have seen a lot of designers making mistake, having an incorrect band radius. So point number 4 is band radius. Make sure you have the right band radius according to your tools. So first advice from my side is go and have a look at what tools that you have. Consider the inside radius that you will get in real life using your tools, and use those tools and use those band radius to design your parts. Having a right band radius makes a huge difference in getting your part accurate and in a good shape. After the band radius, it comes to point number 5. Point number 5 is bending angle. Bending angle is so important to consider because you will get a different bend angle using a different toolings. For example, you can't do 67-degree overfold or 60-degree overfold in a 85-degree die that you have available in your workshop. So those kind of considerations that you have to do before you start designing the parts. Make sure you have a good understanding of the tooling that you have in your workshop and you design your parts according to that. Point number 6 is one of the most important point in all the sheet metal designing, which is K factor. K factor, understanding a K factor is a really big challenge for many designers, and they do not consider the K factor before giving the jobs to the floor. I have seen so many failed drawings causing frustrations and throwing up the tools because the designer or the detailer did not consider the right K factor to create a laser cut file. To understand what K factor is, just check out this video. It will explain everything on sheet metal, and you will have a better understanding of K factor after watching this video. Let's come back to the topic. Understanding a K factor is a very important thing, and make sure you have the correct value added into your designing software, whatever you are using, either SolidWorks or AutoCAD or Solid Edge, but make sure you have the right K factor value in front of you before you start doing or before you start designing the parts. Next one you need to understand is the hole distance. Lots of new designers starting in the sheet metal field does not understand the importance of having a right hole dimensions in the sheet metal part. For example, if you have a hole that is too close to the fold line, it is most likely to deform and screw up the part. That means you cannot fold a hole in a way that it is going to fall into the V that you have. Normally, for thin metal, you need to have minimum distance for the hole is, so whatever V you have, half it and add 1 mm into it. That needs to be the minimum distance for sheet metal holes. Also, I've seen sometimes people do not consider what is the minimum thickness that they can cut or minimum hole dimension that they can cut. Ideally, you minimum hole dia is equal to the thickness of the metal. Next point is bend distance. So bend distance, consider the minimum flange distance is a very important topic, and it is ideally calculated by V size divided by 2 plus 1, same as the hole distance size. You are not going to fold anything in because it is going to fall in a V block. Next point is the clearance. If your parts have things like punch or stamping later on, make sure you leave enough clearance so you can put the parts into the die, and the other tooling would have enough clearance to fold or stamp or drill or punch those parts in a way that you require. Thank you very much guys for watching. Please like, share and subscribe. I will see you in my next video.